Ladies and gentlemen, my name's Paul, and in this Gaming.com video, we're going to be discussing DirectX 12. Yep, that old chestnut. Microsoft are introducing PIX to the PC, and are hoping to allow developers to better optimize titles for the DirectX 12 code path. So, as a bit of backstory, PIX is already available for the Xbox, and it allows developers to do things such as analyze what's going on in a game on a scene-by-scene basis, or even on a frame-by-frame basis. So for the sake of argument, let's say a particular scene, they say, well, you know what, in this particular scene we need to reduce the number of trees because the amount of foliage is causing issues, and you know it's just eating up too much geometry, so we need to reduce that. Or they might say, well, you know, we've got too many things running on the CPU. Perhaps we need to reduce the number of characters so that the AI will be a little bit lower, so we've got that extra level of performance. In other words, it allows them to tweak, it allows them to optimize and make full use of the console's hardware. DirectX 12 for the PC was heralded with the notion of bringing console-like optimization to, well, the PC. In other words, low-level optimization for the GPU. In other words, you don't have that high level of abstract layer which A, reduces CPU utilization, and B, allows developers to do things like really push compute on the GPU. But the other thing that, and this is what a lot of press really latched onto, was the fact that CPUs could now talk to the GPU on a multi-core basis. DirectX 11 did its best, bless it, but it wasn't really good enough, despite the fact that Microsoft made a few half-hearted, attempts to improve DirectX 11's multi-threading. It just wasn't anywhere near good enough. Mantle was introduced by AMD, of course, and served as the backbone for Vulkan, but also a lot of that, I guess a lot of that research also found its way to DirectX 12. So, with the introduction of DirectX 12's PIX, one should, at least in theory, start seeing developers really be able to optimize the software they're running. Now, there are a few caveats. The first is that it's only capturing DirectX Direct 3D 12 content. It will only support 64-bit apps. This includes UWP and Win32. Not really surprising. Some people are going to immediately say, well, it says x86. No, x86 in this case means 32-bit. PIX only captures data from specific processes that are launched or attached to. It doesn't support child processes. So in other words, if you have a launcher, for example, or a game has multiple, let's just say multiple processes, it launches in the background, you're going to have some problems. There are also, perhaps the biggest problem with this is that the GPU captures will not generally be portable across different GPUs or different drivers of the same GPU. And perhaps even more crippling is the fact that the GPU captures currently are not overlapping GPU work on different queues. This means that if your application uses a lot of asynchronous compute, basically it's not going to be shown up as being executed in a parallel fashion. Instead, you're going to get it in the more traditional serial way. But what it does do is still allows us to find out, for example, the execution of single functions, memory allocation, time capturing. This allows, for example, you to understand CPU performance, threading of both GPU and CPU work, function summary. This is great for figuring out how long, say, a certain task took to perform. So for the sake of argument, let's say that you wanted to do shading on a specific, I don't know, set of geometry, and you thought, well, gee whiz, how long is that taking? Well, okay, maybe I should perhaps reduce the level of detail because that's a little bit in the distance, so maybe just reduce that a hair. That helps a lot, and it will also, at least in theory, allow developers to better put together settings, you know, pre-made settings like high, medium, and so on, and better be able to optimize around that hardware. Now, as I alluded to at the beginning of this video, reception with DirectX 12 has been somewhat mixed. And it's kind of funny because I did actually speak to Scott Wasson in my Vega interview. I'll remember to link it in the video description. And I was talking to him about this, that, you know, what do they believe of DirectX 12? You know, do they believe DirectX 12 is really going to start pushing into this year? And I went into the question with my own preconceived notions. I believe that obviously DirectX 12 is still kind of in its infancy, and he pretty much said that yeah, that's the case. It's like the problem with games development is that it's not. A lot of games development now with DirectX 12 had DX12 added. I'm not saying all games, but a lot of games had it added, excuse me, quite late in the development cycle. So what you have is engines which weren't designed from the ground up, or games which weren't designed from the ground up to fully utilize DX12. Now, I'm not saying that that always is going to be the case, and if you go with DX12, you're going to get double the performance, because that's just completely false. There are going to be situations where multi-GPUs, or the GPU you're using period, the CPU you're using, the amount of memory you've got, God knows what else, is going to, of course, play a crucial role. Second thing, and this is perhaps even more important, it depends really on the software they're running as well. So, and I know I always use this example, but let's say you're an indie developer creating something like Limbo, doing low-level optimizations to squeeze the best performance you've got out of something like Limbo or Inside or those styles of games doesn't really make that much difference. On the other hand, if you're putting together a AAA title like, for example, the next Call of Duty, Battlefield, or anything along those lines, then yeah, you're going to start noticing a difference, because inherently the engines have massive open environments with massive amounts of stuff going on at once. I also believe that as GPUs become increasingly better at handling compute, as CPUs become increasingly more multi-threaded, and quite frankly as developers just get more acclimatized to working with DirectX 12, and remember, a lot of DX12 stuff has really benefited from the Xbox with the PC. And this is somewhat what Scott was saying to me with the whole Doom scenario as well. Like, Vulkan on Doom on the PC benefits the hardware, AMD hardware, quite well, because a lot of the console optimizations are basically baked in to Doom. So what you have is this I guess synergy where the console optimizations just inherently improve the PC optimizations with Radeon hardware. But as AMD and Nvidia both improve their drivers, as developers start to improve their knowledge of the hardware, and of course as Microsoft, and perhaps this one's even more critical, as Microsoft start to release more code to give developers examples as they start to improve the tools so that developers can actually optimize, I do believe DirectX 12 is going to be worth it. Anyway, those are my few pennies on the subject. Hopefully you've enjoyed the video. Normal stuff, if you've, well, liked the video, well, you know, click the like button, leave a comment, catch me on social media, all of the normal jazz. I'll see you soon. Take care. Bye for now.